My name is Tom. Today I'll be talking to you about servers, why they can't be trusted, and how we mitigate that in EteSync, which is a project I work on. And this is, you can find the slides over there or on the FOSDEM website. You can scan the QR to get the slides. And this is it. Let's jump in. So first of all, let's look at simple server communication. So the most basic thing, how it looks like. So you have Alice, the user. Probably she uses TLS or whatever variation and connects to the server. So everything is encrypted. And let's, for the purpose of this talk, let's assume that everything between Alice and the server is safe. There's no man in the middle. Although this is actually a risk, especially if you use a company laptop and they install a root certificate or anything. It is a risk. But let's assume not. Let's just only talk about the servers today. So let's start by that communication. What are we leaking when we do that? So first of all, we have data. We actually, if we use Gmail, for example, we leak the emails, we leak the calendars, we leak any personal notes that we may have, our deepest secrets, secret business information. We're gonna do M&A, like buy this company or whatever. And also there's what's usually looked, as less important, like the metadata. So the IP address, which, if you're a government, you can link it back to a certain person. But at the very least, you can probably get location information out of it. A social graph, so who do I know, who knows me, group of friends. I'll cover that more in a second. Time of access, so when in the day I log in. So if I always log in, let's say from 9 to 5 in London time, you can probably assume, this is my business hours. I work in London, I live in London. So that also, a lot of information is leaked there. Which data is used and how often. So for example, you will always call a certain person, that person is a person of interest. Always open a certain file, that file, you just hacked my computer, you want to know, you saw the last 10 files I used, those are probably more important than my book report from 6th grade. And when specific data is accessed. So for example, if I have my computer, during work hours, I open this. During after hours, I open this, so this is personal information, this is work information. There's a lot actually being leaked there. So let's look at some parts in specific. So let's look at exploiting social graphs. So we have a group of people. We know that we have 4, rebels or whatever we're trying to catch. We already caught 3 of them, A, C, and E. And now just looking at the graphs, by who they know. So let's assume they all use Signal. So just by getting access to the Signal server, which Signal is usually, it's end-to-end encrypted, everything like best practices. But still, because they leak the social graph, who knows who, we can know that B, just like you see by all the connections, that B is actually part of the group. And we also can see that D, that we actually never knew existed, is also part of that group. So all of this, by using best practices, end-to-end encryption, all of that, this is a leak. And another example, actually, I really like giving, is exploiting access patterns. I don't remember which government agency it was that wrote a report about this. But these are 2 mobile phones. And the graphs are access times to the server. So essentially when they're on. So one of them is a burner phone used by a spy, and the other one is a normal phone. It's very easy to see. It's a good idea to turn your phone off because then you can't be triangulated. But you see, you still leak a lot of information. Now all of a sudden you're a target. And if you're A, you're not a target. Your information is no, but you don't stick out. But this is all a bit theoretical. So let's take it to something more practical, which I care about. Let's talk about CardDAV. So CardDAV essentially is how most information, most address books nowadays are synced. It's used by iCloud, Nextcloud, OnCloud, everything with cloud in the name essentially. And it's a good, it's a standard, so it's great. It's interportable, supported in every client. But let's look at roughly how it works. So you have Alice, Bob, Cher, all of those are my contacts. You just have files on the server in clear text with all of the contact information in each one of them. So let's look at how, what's leaked there. So first of all the address books information. So yeah, if I hack the server, I have all the, I have all the phone numbers, emails, position in the company, relationship if you put it. I'm very pedantic. I have addresses, I have everything in my address book. IP address, obviously, you're connecting to a server. Social graph, because you can see which contacts I have and which contacts have me and what groups I group them. So if I had, people that work on Enlightenment, which is another project I work on, this already gives you a very good image of groups. time of access, obviously, when I access the server, and again, which data, like we covered, which data, when do I use it, and everything. So let's solve some of them. Like it's not a big deal. You can use Tor to hide the origin. Tor is not always perfect because, first of all, it's a bit slower nowadays. It's a bit slower. But also, it doesn't work with all services. So Cloudflare and other services flag it because a lot of spammers use it. So you'll have issues. You'll have to fill in a lot of captchas while using anything. And another thing, which I don't know actually if this is verified, but I would assume that every government agency flags you as a person of interest the moment you use Tor. Like, it's easy to detect, and I'm sure they do it. But it's not verified, so don't take me to it. We can try to control the access patterns. So I don't remember if it's true, but I think Satoshi Nakamoto, the guy who did, or guys or girls, or I don't know what combination of things, that did Bitcoin, used to write posts and emails like in different times of the day, so you can't know which continent, which country, which everything is from. And another example of access patterns is when, another Bitcoin example actually, that really, I don't know, it was a lot in the news, is when the guy behind Silk Road, Rolf Ulbricht, was caught. They were monitoring the server and waiting for him to log in. And then by just seeing this access pattern, they were waiting for him to unlock everything that's encrypted. So they waited until logged in, and then this was enough of a queue for them to raise him and go after it. And this, again, another very easy leak that is obvious, but we leak. And another solution, obviously, is trusting the server. So using a trusted provider, I don't know, Google or whatever that you trust, or hosting your own. Obviously, the title of this talk kind of means that I don't believe in any of that. So should we even trust the server? It could get hacked. We get a lot of hacks. Everything is hacked nowadays, and every server is running a lot of complex software with so many places to have issues. And even EteSync, I don't even know how many dependencies I depend on, because I want the Java, like for the Android client, want the Java runtime library, and I want probably some, not Google stuff, but I don't know. I have JSON, like parsing JSON. There's such a big attack surface nowadays that just assume you're going to get hacked. So it's better to protect them and be proactive. It could get stolen. Like literally, someone could break into your house if you're self-hosted at home, steal the hard drive, and just steal all your data. Again, maybe it's not interesting for you, but if you're a high-profile lawyer that does a lot of high-profile cases, you are a target that will get attacked, and this is a real threat. With hosted, you can have rogue employees, so employees are actually selling your data because they're evil, or I don't know why else they would do that. I mean, maybe compelled by the government, or compelled by the mafia, or whatever. All of those risks that exist. And also, when it comes to self-hosting, and don't get me wrong, I think everyone should self-host. It's a lot of work. You have to be a techie, at least to an extent, to do it. You have to make sure that your finger is on the pulse with making sure that you're always updated to all of the latest security issues and all of that. So it's a lot of work, and it's not that available. So hosted solutions, I think, are essential to make a private internet or private world. And this is why, again, I try to make sure to create an environment where the server can be trusted and we can use hosted solutions safely. So let's talk about reducing service trust. So first of all, end-to-end encryption. I'm biased, but don't use a project that does not, or a project or service that does not do end-to-end encryption. It comes with flaws, but for example, if you lose your key, all your data is gone. This is why it's not mainstream and everywhere, but still, there are solutions to that as well, like escrow of keys, just end-to-end is the bare minimum. You can do mostly offline operation, if possible. So let's go back to the CoreDAV example. Let's assume I want to write a web client. So normally how I would write it, you have a website, you click on a link, open a certain page, and when that page is open, it's requested from the web service. I want to see Alice's contacts. I click on Alice. The page is requested from the server, so the server knows I viewed Alice. Another alternative would be to write it all in JavaScript, and then on the first time you visit the website, all of your contact list, which is probably, if you're crazy, 1 megabyte, which is less than my logo, most likely. I mean, in most of the JavaScript framework, it's really low compared to everything else that you serve. And then all always access the data from the local storage, from the local cache, and then you don't leak that information. So there are a lot of solutions to make that possible. And another thing, and I put it in a question mark because you can fake access patterns. So you can, for example, when you edit a contact, you can fake edit 5 others every time randomly, so you don't know which one you edited. But I'm sure, I'm not a mathematician, but I'm sure that with enough statistics, it will be uncovered. So I don't know if this is actually a sustainable solution. So let's talk about hardened CardDAV. So we know the problems, we know how to solve them. Let's start solving them. So first of all, as you can see, we now use IDs instead of the names, so everything is secret. We end-to-end encrypt all the data, so nothing is visible to the server. And you can see which one is changed or anything like that. But there are still issues. So for example, let's assume I just finished this talk. Actually just before, I met Caleb. We exchanged contact information. I put it on. Now all of you, including whoever's seen it online, knows that the moment this file was created, it's Caleb. Like, you don't need to know the data, but you know by the date of creation and the fact that it was on camera that it was added. This is enough. This is enough. And now every time, for example, I edit it or I call him and it updates the last time he called, you can see, oh, Tom called Caleb. It's like all of this information, like it's not obvious because, oh, it's encrypted, it's fine. No, it's not fine because it's still identifiable. So it is a risk, and it's a risk that's not solved by end-to-end encryption just like that. Okay, let's go. This is it. Like we're safe. This is it. This is all we can do. But it's not actually, because we can do much better. And let's go at it. So as I said in the beginning, our data, like our servers cannot be trusted, so our data can also be manipulated by the server. Let's look how. So I don't know if a lot of you do encryption, but like a basic example of bad crypto is encrypting but not signing, or encrypting but not doing any sort of message authentication. So let's look at a crazy example, which it doesn't exist in real life, but like similar examples do exist. So I want to have some access level storage in my app. Let's, I don't know why, this is the people that my app automatically will accept requests to join a group. I don't even know what it does. So it's encrypted, so I know the server can touch it. And the default level is 0, 0, so no level. But just by changing 1 bit or whatever you want, you can just scramble and give another encrypted chunk, all of a sudden, it changes to 19, like the level. So I can't control it. I don't know how to change it to be 1, but 19 is already good enough, especially if you do Boolean comparisons, so you do true or false. So this is just by being able to touch the data without, it's end-to-end encrypted, I can't see it. This is enough to manipulate me as a user. Again, this is not a real problem because you just HMAC or use message authentication codes or signatures to make sure no one does it. But this is a real problem. Let's look at another thing. So we have our hardened CardDAV. And I just added, again, a contact, or I just added a to-do item, or I just added a calendar event. Because let's say I have a court hearing next week. I just added it. And my adversary, like the people on the other side, want me to miss it, obviously. So they saw I added it. They hacked my server and just omit this file. I have no way of knowing. Everything, again, end-to-end encrypted. Everything is safe. But the file is omitted. There's no way for me to know the file was omitted because this is normal operation. Of course, files get deleted, get added. I add a contact. I remove a contact. So this is another problem. And again, a server can't be trusted. So this is easy to solve. You just verify the state. So you do any sort of signature or checksum with message authentication code or whatever. And then every time this is changed, I will get notified. But again, there's another problem with that, which is data rollback. So let's assume I just had a state that is valid just now. I added a contact. Now people want to remove this contact. All they need to do is serve me, again, the old state before I added the contact. This is it. So again, a server, no access to my data. I'm signing the whole state. I'm making sure that the state cannot be manipulated. It's still, I can get attacked. Which is, again, don't trust your server. Never. So the solution I came up with, and it's not, obviously it's not me, it's built on top of a lot of work by a million of other people, is tamper-proof journals. So what it is essentially is that instead of adding files, or instead of adding contacts, what I do every time I add an entry. So for example, here I add Alice, and then I added Bob, and then I realized I had a typo, so I changed Bob, and then I deleted Alice because we're not friends anymore. And all of this is just like every time append only, so you can't really know which data is which because everything looks like, actually let's jump to this, like an encrypted blob. So this is how it actually looks to the server. You're just like, oh, something happened, something happened, something happened, and something happened. And everything is end-to-end encrypted, so there's no way for the server to know what happened. And also the server can't manipulate anything because the UID is every ID of every chunk on the block is a verification of the contact in the previous block. It's essentially like Git, just encrypted and signed. So every time, if I try to remove this, I'll get an integrity error. If I try to just switch them, like change the order, again, an error. And all of this protects from that. And because I can't remove anything, I only append, I can verify that nothing is missing. Because if I added a contact here, and then I added a contact on another phone, so the server can potentially just not show me the new addition. It can show me, trim the log for me. But then when I try to add again on the other one, it will get a clash. They cannot, there's no way for the data to be correct. Unless, again, they could diverge it completely. But then the server has to identify each time to know exactly which is which client, which is a difficult task. Okay, so let's go on. So let's see how we protect. So as I said, it's immutable. So data can only be appended. No modifications are allowed. Everything is verified by the client every time, like Git. So every time you had an error with Git, you would get the same error here if a server was trying to manipulate your data. It's signed, so it can't be manipulated or faked. You know it's you. Again, preview ID is also signed, so there's no omission or reordering. And again, like Git, as you can see, I very much like Git. Everything is distributed among all clients. So let's assume the server, and this is something I didn't talk about actually in the hardened CardDAV. Let's assume a server was hacked and everything was deleted. This is it. I'm like, actually, you know what? I don't care about him finding out. I'm going to delete everything. This is something you can protect about. But if everything is distributed to the clients and every client does not say, oh, it's missing on the server, it means it's deleted, I should delete it here. Instead, they verify it. So in the case of mass deletion, they will just not do anything. That's clients. And we'll be able to recover all of the data from the clients themselves. Let's talk about previously unsolved attacks that were not solved in the CardDAV case. So which data is accessed and modified? Everything is done locally. So there's no access, like no one cares about access. And modified, you know there's a modification, but you don't know which one because that part is also encrypted. So this is actually, it's not entirely true because, for example, you can do some analysis to know by the size of the message. So for example, a contact is probably 1 kilobyte, but a calendar event is maybe, well, actually it's probably the same size, but like an image would be much larger. So you could do some analysis to figure out what's what. But again, like I said in the previous example, you can fake it. You can fake it and you can hide it and you can create fake messages, but it's wasteful. Data omission and rollback we solved, as I said. So that's just like a few words about what EteSync is and how it's used there, like a real world example. So essentially it's a secure end-to-end encrypted and journaled, obviously, uses a journal. Personal information, cloud sync. So essentially syncs your contacts and calendar among your Android devices or web, or there's also a CardDAV and CardDAV proxy for the desktop. So you can just use Thunderbird or whatever you use. Yeah, I use it everywhere. It's seamless on Android. So like you just use the same apps you always use, and it works like a Google account, essentially, just encrypts in the background. The journal format is very simple. You have the UID that I mentioned, and then like in every time, like I change, I snapshot, again, like I snapshot the whole format itself. So all of the calendar event is snapshot every time. So even if I delete, I have a latest snapshot of what happened. Another nice benefit of this is the change journal. So now I know this is like my shared reminders calendar. So I know I need to feed the cats, go to the supermarket. And then like all of a sudden I can see like someone edited this event and someone deleted it later. So I know that, for example, my lazy flatmate decided to remove that task that was associated, that we gave him to do. And you can really see who changed what, when it was changed. and also obviously recover lost data, because if the event was deleted, now we can find all the content that was there. And also, which is super useful, is finding entries based on date. So for example, I met someone today, added it in the contact list. It's been 2 weeks, I want to send them, I have no idea, I forgot the name, I have no idea how to find it. I just go back, it's like, oh, when was that? Oh, that weekend? Yeah, though it's one of those 3, I probably will recognize by then. This saved me a handful of times. Like, okay, one more thing, actually, and then I finish, is signed pages. So as Caleb said in the talk before, one of the biggest problems with serving JavaScript is that you cannot trust the JavaScript is actually really what it is, because the server serves the JavaScript, which is the app, every time. So a malicious server, for example, could just serve you a malicious piece of JavaScript that sniffs all your passwords and steals everything, and you'd be none the wiser. Like Caleb, I was looking for solutions, and I decided to write a browser extension that essentially verifies the PGP signatures of pages. So it's called signed pages. Devs signs the web pages. Users add the public key, the expected public key for a page, and the page, like the URL. And then the extension verifies the signatures. As you can see, this is a page with a good signature, a page with a bad signature. Obviously, you have external JavaScript and CSS, so you probably want to use sub-resource integrity for all of those, and that's already a mechanism in the browser that's safe and verifies all of that. So essentially, by verifying the HTML, the main entry point for your app, you verify everything, and that's add the same level, almost the same level of security that you get with native apps and in the browser. And in the future, we're trying, like, I'm working with Daniel, Airborne.io, which is like a Google Docs end-to-end encryptor. Yeah, he's there. We're trying to do it also for service workers, so you can have it in progressive web apps, so apps that, like web apps that you just have an icon on your phone, because they're not verified, because there's no browser there to run it. Yeah, so this is it, just 2 finishing notes. I mean, privacy is a sacred right. Don't give it up. And once you give it up for everyone, because then we outliers that care about it are signaled out. And don't forget, oh, is this stop working? No, you're the weakest link. So, I mean, this is a famous XKCD comic. Like, in the end, doesn't matter how much encryption you use, if in the end, like, someone hits you with a wrench and tries to steal your password. So make sure, if you have really important information, like double redundancy, so encrypted by multi-keys, like, essentially, there's a lot of, thanks to cryptocurrencies, there's a lot of information nowadays about advanced crypto. So this is that, and useful links. If you want website, download EteSync, yeah. My blog, signed pages, a lot of information there. And no time for questions, I assume.
Oh, you have time.
Yeah. I have time for questions. Okay, so.
Yes. Question?
Over there.
Yeah. Here.
By the way, just I'm gonna, while this attribution, like, so I took a few icons from other places. It's in the slides that if you download them, you can see, like, and obviously the XKCD comic, so just for good measure. Back to this. Yeah.
Thank you. So your journal appears like a single file?
Okay, so the way it's actually implemented, it's implemented in a database. So I'm just like add an entry to the database, and all the servers can see is the UID and an encrypted content.
Okay, so what about scalability? Have you tackled the issue? Have you thought about it?
No, so I haven't, so I mean, I've never, I never worked on a company like Facebook or Google that deals with 1 million of users. Like, I have no idea how it will behave in this level, but at the moment, like, it's not even bothering my server. Like, there's nothing there, and it just uses normal SQL. Like, it's just like you add entries, there's nothing there. It's like, and because I rely on existing technologies, like, so it's not too dissimilar from Git. It's not too dissimilar from that. It's very similar to other things. So I don't see any scalability issues in the horizon, essentially. Any more questions? Yeah, over there.
Since the data set is always appending, do you take care of trying to make it smaller after using it for a long time? Like if you add contacts, delete contacts, etc. Like after 30 years, I mean, in 30 years, I still want to have my contacts encrypted. So would the data set ever increase, and downloading it on my mobile phone would maybe become harder? Or?
Okay, so I mean, it's a good concern. And again, like in Bitcoin, all of that, there are solutions to that to an extent, I think. Like, I mean, you could download only chunks of it and verify those. But to be fair, it's contact information and calendar. like, I challenge you to like get to a gig even. And like by the time you get to a gig, like we'll have enough storage. Like it's really not a concern. Like I don't see how we'll ever reach a point that it's a concern. And I have a lot of users that rewrite and change and add, and still we never reached anything that's even scratching the surface. Like I think the whole database is maybe like 200 megs, and not even. So yeah, it's not a concern at this point.
As a follow-up question to the increasing log and not garbage collecting anything, the sync time for new clients. So, for instance, if you have a new mobile phone and you want to sync all the contacts, it has to go through the entire log, right?
Yes.
Okay, so that could be a problem.
Okay, so you heard the question. I don't need to repeat the question. Yeah. So. Essentially, again, like, I challenge you, like, I don't know how many friends you have, but, like, I don't think you'll get to more than 2,000, 4,000, 5,000 notifications, 1,000, 10,000, whatever. It's still not a problem for a computer. And anyhow, all of this, the data, all the size just gets to less than a meg, which is, again, less than an image on a normal website. So it's really not, it's not a concern. But with that being said, it's not really implemented, but I plan on doing like helping with journal trimming. So essentially, let's assume I added a contact, and then I realized, actually, I don't want anyone to know I added this contact. So what I can do, I can help you recreate a new journal. You can't change the manipula, but create a new one that does not include this data. So you can potentially trim it if you want, if it makes sense. Yeah.
I actually have one question.
Perfect.
What if you lose your phone and you buy a new one, and then you cannot verify what's on the server, you cannot even access your data? What's the plan there?
Okay, so first of all, luckily for me, it's because like most of the problems that usually are associated with end-to-end encryption are actually solved, because end-to-end here means me-to-me. So I don't need to do any secret sharing or verification of who you are, identity. So I use symmetric encryption. So as long as you remember your password, it's not a problem. Like you can install it on how many phones, if you remember the password, which you should. I mean, write down as well. Like you can always recover it. That was the first part of the question. What was the second part? Or that was it?
That was it.
Okay, yeah. So that's solved. And yeah, okay, question there?
Well, just a quick question. Does it still make sense to self-host? I mean, is it secure enough to use a service, like central service for this kind of software?
Yeah. So, you should trust me, but like you shouldn't. So like I wouldn't do anything bad with your data, but like you never know. So I mean, if you think, but yeah, with your data, no. But for example, I have IP. Like if you don't use Tor, I can have your IP. I don't have access times, but I can know, for example, if you don't do delay addition, I can see when you added a contact. So like, I don't know it's a contact. Maybe you changed the calendar of it, but I can see when you touched your phone, when you're awake, if that makes sense. So I mean, there's still some stuff. But yeah, I mean, I don't think so. I think you should use I don't think you should self-host. I think it's too much trouble, and you're probably better off just using the hosted version. Yeah, question here?
So I think we are, thank you very much for a big round of applause for your presentation. And thank you for making this dev room a success. There have been many people, very great presentations. You will find everything online. Now it's the end, but it means also that we can stay and discuss.